to spell littering? Come on, guys. Come on. I know. Alright, you ready? We're gonna learn some new stuff. Yes. Okay. So the first thing that I'm gonna show you, okay, is how to do second fundamental theorem of calculus. There are only two ladies. Okay, so the first fundamental theorem of calculus says this. We'll put FTC number 1. Okay, put it kind of small. Integral a to b, f of x dx is f of b minus f of a. Okay, that you should already know. Okay, that is the first fundamental theorem of calculus. We already learned it. You take the antiderivative, plug in the endpoints, and subtract. Okay, here is the second fundamental theorem of calculus. You're going to integrate a function f of t dt from a to b, but you're going to also take the derivative of it. Okay, and then actually as well, one more thing to change, cross out your b and make it an x, sorry. Okay, so this is what second fundamental theorem is. You're taking the derivative of an integral, okay, and then a is going to be a constant, but x is going to be a variable. So I'm going to put a little star here and put a is a constant, and then x is a variable. Okay? Now, we're going to discover the rule first. It will take less than 1 minute, and then we're going to write the rule at the bottom of the paper. Okay, so first thing I want you to do is use the first fundamental theorem of calculus. Pretend the derivative's not there. We're going to cover it. What's the integral of little f called? Antiderivative. Big F. Which one would I plug in first, a or x? Okay, x is on top, so I do capital F of x minus capital F of a, right? Okay, now, what did I have in the front that I was ignoring for right now? So, put your derivative back. And now I want you to think about, if I'm taking the derivative of capital F of x minus capital F of a, what's the derivative of capital F now? Back to small f. And then f of a is the constant a plugged into a function. So if I plug a constant into a function, I just get a new constant. And what is the derivative of a constant? 0. So really, the derivative of the integral just comes back out to be regular f. What's the only thing that changed from here to here? Instead of f of t, it turns into f of x. Okay? So, here is the rule. Number 2 fundamental theorem of calculus. The derivative d dx of a to x f of t dt is f of x. Okay, and this one should start off easy, easy, easy. Okay, I take whatever the endpoint is, I plug it in here, bam, that's my new equation. But why am I not actually doing an antiderivative? Because there's also a derivative. They just cancel out. Okay? Okay, so ready? So Kimberly, number 1. What do we do?
Wow, that was really
Oh, then help her out, Jenny. Give her a little friendly assistance.
You're not recording.
Okay, it's easy. I am recording it. By the way, Jenny and Kimberly have been ignoring me for the last...
No, I watch these videos later with you.
Uh-huh. Uh-huh. Okay, what do I do? People that actually were listening.
You take f of x.
Just plug in x instead. So instead of t squared plus 1, now it's just easy. Number 2.
That's not, that can't be there.
That is no way that.
It'll get harder, but for now. Okay, number 2, what do? Derivative of an integral, what happens? Just change the t to an x and you're done. So instead of negative 4 over t plus 1, it's negative 4 over x plus 1. Now, look at number 3. What's wrong with number 3?
Because it's sign. It has a,
Well, the sign is fine.
the X on the bottom.
X on the bottom, not allowed. How can I change it?
Flip it.
Keep the d dx, but flip it to be 7 to x, and then what happens to my middle? It turns negative. Now remember, I'm still not going to take the derivative because it's the derivative of an integral. Those cancel out. So what's the only thing that happens with my y's? They turn into x squared sine x. Okay, but again, remember, no plus c, because if I take the derivative of the c after I put it there, it goes away anyway. Okay? All right, let's work through number 4. Okay, so we have a function right here. Notice that capital F has an integral in it. So the first thing they ask me to find is capital F of 2. Well, then all that I have to do is take 2, plug it in for F. What would I have then?
Sign of pi over.
Now, that's if I'm taking the derivative of the integral. Right now, I'm just plugging in. So if this is f of x and I want f of 2, I'm going to put a 2 here. And I'll have the integral from 2 to 2. Why is it 0? That's correct. Because it's the same number, top and bottom. So remember, I only use fundamental theorem when I take the derivative of an integral. So if it's an integral, I work it out regular. Okay? So now go to part B. This is f. I want f prime. What do? I take the derivative, but what am I taking the derivative of? An integral. So I just take the x, whoop, yeah? So I'm doing d dx of 2 to x sine pi 6t, and that just turns into sine pi 6x. Okay, so I don't use the rule you just learned until you're taking the derivative of the integral. So when I'm going from f to f prime, that's when I use my rule. Okay, then go down one more. Now I want f double prime. That's going to be taking the second derivative. So if this is the derivative, what will the second derivative be? Derivative of sine is cosine pi 6th x multiplied by what? Pi 6th. Okay? So when I take the derivative the first time, it just cancels out with the integral and it leaves the equation the same. Then when I take the derivative the second time, I'm actually taking a real derivative. Okay? Now look right next to that at part C and E. What's the only difference when I get to those parts? I'm plugging in numbers. So let's say on C I'm plugging in a 2. Well, then I'm plugging in a 2 right here. So it'd be the sine of pi 6 times 2. What is pi 6 times 2 the same as? 2 pi over 6, which reduces to what, though? Pi thirds. Or 1/3, yep. And then what's the sine of pi thirds? Pi thirds is here. How many sine fingers on the bottom? Root 3 over 2. Okay, look at the next one. I want f double prime of 0. Well, then I plug 0 into f double prime, which is here. Well, then I want pi 6 times the cosine of pi 6 times 0. What's pi 6 times 0? 0. What's cosine 0? 1. Pi 6 times 1 is pi over 6. Make sense? Okay. So, turn the page. It'll get a little weird. A little bit harder, but not too bad. Okay, but then look at how many examples we're going to do of this. Okay, by the end of this packet, if you don't get it, then I'll be very surprised. Okay? So, take a look at your first example. Okay, it says the graph of a function f shown above has 2 line segments. Okay, duh, look at it. You can tell that. Then it says right here that g of x is an integral. Where does the integral always start? 0. Where does it always stop? Whatever x is, right? So let's say that I'm doing part A. I want to find g of 1. Well, then what do I do with 1 if I know g of x? I take 1, I plug it in where the x is. So I'd have the integral from 0 to 1 of f of t dt. Now, what is my graph of? F. So how do I do an integral of f from 0 to 1? What do I find? Not slope, it's an integral. Area. What shape is that? Triangle. How do you find the area of a triangle? 1/2 base times height. My base is a 1, my height is a 3, so it's 1.5. Make sense? Okay, now let's do part B just real quick. We'll come back to part A. What if I want g of 0? Then what do I want? Yeah, I want g of 0. What am I going to do? The integral from 0 to 0 of f of t dt. And do I even really need to look at the graph if the integral starts and stops at 0? Oh, it's 0. Okay, now let's do one more. Let's do part C. How will I find g of negative 2? Plug negative 2 in where? At the top, where the x was. Okay, well then 0 to negative 2, what shape am I shading there? Two triangles. What's their area? It cancels. What's it going to be? 0, because my top triangle is positive, but my bottom triangle is negative, so those are going to end up crossing out with each other to just be a 0. Now, if they didn't cancel out, what do you notice about the endpoints? They're backwards. So remember that if it didn't cancel out, I would have had to remember to change the sign because it's backwards. Okay, but we'll look at examples of that. Okay, next I want g prime of 1. So I want you to take a little break, come up here to the top. If g of x is the function 0 to x f of t dt, what will g prime of x be? Yes. Okay, what Stephen said. If I need to take the derivative of this integral, then it's just going to be the x subbing in. Because why? The derivative cancels out with the integral and leaves f the same. The only thing that changes is I switch my t to an x and then I'm done. What will g double prime be? F prime, because what's the derivative of f? F prime. Now, what is this a graph of? We said this is a graph of f. So f of x is going to be the y value. What will f prime of x be? The slope. Okay? So let's go through our parts A, B, and C. We're going to find the primes of all those numbers. So I found g of 1. Now I want g prime of 1. What is g prime of 1 the same as, though? F of 1, right? Because we know what f is now. And then look at your graph. At 1, what's the y value? 0. Okay? Now let's go over to g prime of 0. What's g prime of 0? It's the same as f of 0, which is the y value at 0, which is 3. Okay, next one. I want g prime of negative 2, but because g is an integral, g prime is regular f, and f of negative 2 is what? Negative 3. Okay? Next, I want g double prime. What is g double prime the same as? The slope f prime. So if I want g double prime at 1, what am I looking for in the graph? F prime at 1, which is the slope. And at 1, what is the slope of this line? Okay, m equals negative 3. Okay, remember you're just counting the rise over run, so I'd have to count down 3 over 1, down 3 over 1. Okay? Next, I want g double prime at 0. Well, that would be f prime of 0. And at 0, what's f prime?
I don't know.
You know it. What'd you say? Okay, yeah, it's a corner. So what's the slope?
0.
No. DNE. Okay? So it's DNE because remember, you cannot take the slope at a corner. Okay? Alright, then next one, I want g double prime at -2. That'd be the slope at -2, which is this line segment. What's the slope of that line segment? Well, no, count, rise, over, run. Up 3 over 1. Up 3 over 1. What's the slope? 3. Okay? Yes?
Yeah, a little bit.
Okay, it's only going to get worse if you don't get it. So turn the page, and I guess we'll come back to the rest of that. But I need y'all, some of y'all it seems like, or I don't know. So let's do one more. Let's see if you can do it. Okay?
She'll let us do this by ourselves.
Well, no, you'll do some by yourself, but not right now. Okay, so look at A. I want g of 6. This is a graph of what? F. What is g? G is an integral starting where? Always starts at 2. Where does it always stop? X. So when I want g of 6, what do?
Plug in the X.
I plug in g of 6 equals the integral from 2 to 6 of f of t dt. And then how do I actually find the integral? I check the graph or the area, right? So 2 is here, 6 is here. I've shaded this lovely triangle. How do I find its area?
Base is 6.
Okay, 1/2 base times height. How long is the base?
4.
How long is the height?
4.
So 1/2 4 times 4 is 8.
Let's go.
Okay, now when I move to g prime, I'm going to be taking the derivative of this. So this is where I'm going to stop and show my work at the side. If g of x is the integral from 2 to x of f of t, what will g prime be? What do I do with this guy? Just whoop. Regular f of x, which is what in the graph? The y value. Then when it asks me for g double prime, what am I going to tell them? F prime, which is really the what? Slope. Okay, and I would go up to the top of your paper, fill that out, and then you don't have to think about it again. So if I want g prime of 6, what am I really looking for?
No.
F of 6, which is the point. At 6, what's the point? 0. Okay, what about g double prime at 6? What will that be?
Isn't that the slope?
Yep, f prime of 6, which is the slope. Count the rise over run between the pretty points. Down 4 over 2. So a slope of -2. Make sense? Because remember, you're going down 4 over 2. Down 4 over 2. Okay, let's come over to this one. Now I want -2. G of -2 is the integral from 2 to -2 of f of t dt. Now remember, I have to plug in the number they gave me where x is. So what's the first thing that you notice about that integral? It's what?
Backwards.
Okay, it's backwards. Where's -2 supposed to be? On the bottom, but since I had to plug it in for x, it's on the top. So when I find the area, I'm going to change the sign.
Negative.
Okay, yep. So from -2 to 2, that's this little triangle right here. It's 8, but will it be positive or negative? Even though the area is above, it's -8 because it was backwards. Okay? Next, I want g prime of -2. What is g prime the same as? Regular f of -2. And what is regular f at -2 in the graph? It's the y value. It is 0. What about g double prime at -2? That will be f prime of -2, which is the y or the slope. And if I choose 2 pretty points and I count my rise over run, I go up 4 over 2, so my slope is 2. You don't change that one to a negative because it's not downhill. It's an uphill line. Make sense? Okay, so from here, we're going to go on to answering more parts of the FRQ. Hopefully you get the general idea. But what is G prime?
G prime is
F. What's G double prime? F prime. Okay. So for part C, I want to find relative mins and maxes and critical numbers. So I want you to think back to the definition of those things. A critical number is anywhere that G prime of X is equal to 0 and changes sign, right? If it changes plus minus, it'll be a max. Minus plus, it'll be a min. But I don't have a graph of G prime, but what is G prime the same as? F of X equal to 0 and change sign. So remember that even though I don't have a graph of G or G prime, I know G prime is really F, and that's what my graph is. So on your graph, where do you have critical numbers? There are 4 of them. Where is F of X equal to 0? Yes? Negative 2, 2, 6, and where else? 10. What type is negative 2? A min, a max, or neither? How does F of X, which is really G prime, change sign? This is a min. What type is 2? Neither. What type is 6? And then what type is 10? Neither. Okay, so now we just have to write that out. But remember, why am I looking at F of X? Because that's really what G prime is. Okay? So I would put X equals 2 and 10. Those are both neithers. Because G prime of X, which is really F of X, doesn't change sign. Okay? Now I grouped 2 and 10 together because they're both the same type. What would I say about X equals negative 2? Okay, it's a relative minimum because why? Because G prime of X, which is really F of X, and it changed how at negative 2? Negative to positive. Okay, and then what would my last one be after negative 2, 2, and 10? What's my last one? 6. What type is 6? Relative max. Because G prime of X, which is really what? F of X changes from plus to minus. Okay? Okay, part D is perfect after the quiz we just took last week. How do I find absolute extrema? These are relative extrema. How do I find absolute extrema? I make a candidates chart. What goes in my candidates chart?
Is that endpoints?
Okay, so negative 5 and 4. And then what else? Critical numbers between that. So out of all my critical numbers, I had a 2, a 10, a negative 2, and a 6. Okay, negative 2. Now, should I put 2 in there if it's a neither? No. Okay, and then 6 is too big, so I don't have to worry about that. Okay, have we found any of these already? We found G of negative 2. What was G of negative 2? So I'm not going to find that again. I already know that. Okay, and then I found at 6, but that doesn't really help me, right? So let's go to 4. If I wanted to find G of 4, we'll show our work over here. that would be the integral from negative 2, or wait, where's my integral? Oh, right here, it's positive 2 to 4 of f of t dt. Now, think about, if I'm going from 2 to 4, instead of that whole orange rectangle, or pink rectangle, 2 to 4 is only this part of it. So if the whole thing is 8, what's half of that? 4. So this is 4, because it's half of the rectangle. And then the other one I would need to go back and find is g of negative 5. G of negative 5 would be the integral from 2 to negative 5 of f of t dt. Okay, it is backwards, and from 2 to negative 5, what do you notice about your areas? Oh wait, it can't go to negative 5. That must supposed to be a negative 4. The graph doesn't even go to 5. Change that to a 4. Otherwise, it doesn't really make sense. Okay, you're switching that to a 4. Otherwise, the graph doesn't go back far enough, okay? So, 2 to negative 4. Here goes my graph. Ready? 2's here. I'm shading all the way back to negative 4. What happens with these two triangles? Cancel, so then all I really have left is 1/2, which is 4. Positive or negative, though? Negative 4, because why? Backwards. Okay, so 2 of my triangles cancel out, and then the remaining one left was above, but it was backwards, that's why it's negative. So then out of my chart, which of those numbers is the smallest? Okay, so absolute min is negative 8. What's the absolute max? 4. Now, where do they occur at? Okay, that would be a different question. Okay, we have 2. Well, let's do one more part left, and then we'll wait to finish the rest next time. Okay, points of inflection occur when g double prime of x changes sign. But what is g double prime of x the same as? Okay, that's the same as f prime of x, which is the slope. So really, I want the slope to change sign. So put x's on the graph everywhere that you see the slope change sign. Where does the slope change sign? 0, 2, 4, 8, 10. Very good. X equals 0, 2, 4, 8, 10. And then because g double prime of x, which is f prime of x, the slope of f changes sign. So really, if you remember how to answer these questions from the first semester with graphs of f prime, it's almost the exact same thing. You're just adding one extra layer because you have the integral in there, okay? And then remember, we used to always mark these with x's, so I would put an x here, in a different color, here, 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 and here. Because my slope goes up to down, then down to up, then up to down, then, you know what I mean? Yeah? Okay, I would not try your homework tonight. Let's work through maybe one. I know you're just really wanting to do it. I'd give yourself one more day of examples before you start. Otherwise, if you mess it up, you'll have to redo it.
Yeah.